Identify the key features and then graph. The first thing that I'm going to do is convert this equation that's initially in standard form into vertex form. And to do that, I'm going to complete the square using x squared and the 10x. So here, I'm going to get x squared minus 10x. I'm going to add the quantity that's going to give me the perfect square trinomial. But instead of adding this to the left-hand side, I'm just going to subtract it at the end of the 18. So plus 18 minus that quantity, which is going to be the coefficient of x, here that's negative 10, divided by 2, and then we're going to raise that to the second power. Now that I've done this, I've created the perfect square trinomial, and I can factor this into its binomial squared by grabbing x and grabbing the quantity inside of the parentheses. So here I'm going to get x minus 10 over 2. This is all going to be raised to the second power. I have the plus 18, and I'm going to subtract. Here we get negative 10 divided by 2. That's going to be negative 5. Quantity squared. Let's simplify this a little bit. So here we get x minus 5. Again, 10 divided by 2 is 5. Raised to the second power, 18. And then negative 5 to the second power. That's going to give me a positive 25. To completely finish the problem, now we got to combine the 18 with the negative 25, which is going to give me a negative 7. And that is going to be the vertex form. X minus 5, quantity squared, minus 7. Now, because my leading term here, my a value, or I should say my leading coefficient, is a positive 1, I'm going to get concavity up. If I had a negative number here, then it would have been down. For my y-intercept, I'm going to turn to the original equation because in standard form, the y-intercept is very easy to obtain. It's just the c value. That's going to be 18 as a coordinate. We're going to record it as 0, 18. Now I'm going to turn my attention to the x-intercepts. And to get the x-intercepts, I'm going to get the vertex form and set that equal to 0. So here I'm going to get, let me rewrite it here on the right. X minus 5, quantity squared, minus 7, set that equal to 0, and now we're going to solve for x. To do this, I can add 7 to both sides of the equation. On the left hand side, the 7's are going to cancel out, leaving me with the x minus 5 quantity squared. And on the right hand side, 0 plus 7 is going to give me 7. To get rid of the square here, or the power of 2, we're going to square root of both sides. And on the left hand side, the square and the square root cancel out, leaving me with the x minus 5. And on the right hand side, since 7 doesn't have a perfect square, we're going to leave it as plus or minus root 7. Now here, to isolate x, we are going to add 5 to both sides of the equation. And I get that x is equal to 5 plus or minus root 7. Now this would be the exact form, but our ultimate goal is to graph this. So I'm actually going to get the decimal approximations. So let me begin by splitting these up into 5 plus root 7 and 5 minus root 7. And with the help of a calculator, I got the approximations to be about 7.6 and about 2.4. I'm going to use these approximations as my x-intercepts. I'm going to go ahead and record these in coordinate form. So I'm going to get 2.40 and 7.60. For the axis of symmetry, that's going to be the h value. And the h value is the opposite value of the one you see inside of parentheses. So here, the opposite of negative 5 is going to be positive 5. We're going to write the axis of symmetry as x equal to 5. As for the vertex, that's the h and k, the coordinate hk. So in other words, it's going to be the axis of symmetry, which is 5. And that's going to get paired up with the k value, and the k value is the term at the end. So here we get negative 7. And now that we've obtained all of the key features, we are ready to move on and graph this equation. So here I've recorded the key features. So let's begin by graphing the vertex, which is at the point 5, negative 7. So we're going to go 5 units to the right, and then we're going to go down all the way to -7, which is going to be right here. Once we graph or plot the vertex, we're going to use the axis of symmetry, or we're going to trace the line of reflection here so we can reflect points if needed. And now notice that we're in a little bit of a situation because the y-intercept, the 0, 18, we're not going to be able to graph it here. It's going to extend beyond. And for the x-intercepts, the 2.4 and the 7.6, we can use our best judgment to plot them, but there is a level of anxiety on where exactly they should be marked. So I propose this idea whenever you are faced with this scenario. To get a decent sketch of the parabola, we can follow the 1-3-5 method. So here we have 1, 3, 5. That's the pattern of change. And now we're going to turn to the a value, which is 1. We're going to multiply these 3 values by the a value, but notice that that's not going to change. So let's keep the 1, 3, 5. And now, beginning at the vertex, we're going to go 1 unit to the right, and now we're going to go up 1 unit. So doing that, we get our second point. Let's do it again. We're going to go to the right 1 unit, but this time we're going to go up by 3 units. So 1, 2, 3. That's going to give us the third coordinate here. Let me go ahead and plot that. And then let's do it one more time. So we're going to go 1 unit to the right, and this time we're going to go up 5 units. 1, 2, 3, 4, 5. Okay. And now, even though we weren't able to plot the y-intercept, and we were still able to get a decent sketch of this parabola, we can reflect each of these points. So beginning with the first point, it's 1 distance away, so we're going to go over 1 distance away. The third point here is 2 units away from the axis of symmetry, so we're going to go over 2 units as well. And then the final point here is 3 units away from the axis of symmetry, so we're going to go over 1, 2, 3 units. Once we have the points, we can connect them with a curve. And actually that was a very bad sketch here, so let me try to do it one more time. Somewhere around there, because notice that this kind of has to go at 2.4. So that, I believe this would be a better sketch of the function here.